Question 2.1. We are now going to move over to some number patterns. And it says consider the following number sequence. We've got here 10, 7, 4, and 1. And our first question is, or instruction is, to determine the general rule for the sequence, or the nth term. Now remember, in class I keep on reminding you that the general rule can be referred to as the, general rule. It can be referred to as the nth term, or they can ask you to calculate or determine Tn. All of these things are the same thing. Okay, it is not asking you, when they are asking you one of these three things, they are not asking you to give them the rule in words. Okay, so they're not asking you to say, start with 10, then add this, or then subtract that, and continue. They're not asking for that. They're asking you to calculate that formula, that key, that thing that allows you to calculate any term in the sequence. So you need to do some calculations there and find that general rule, the Tn, the nth term. Okay, so the first thing that we do, or that we have practiced or learnt in class, is we want to establish what is the constant difference. What is the rule? What is the pattern here that allows us to go from the one term to the next term? Okay, so usually, for now in your case, you will have what we call a constant difference. In other words, if I subtract the first term from the second term, I would get some number, and if I subtract the second term from the third term, I usually get the same number, and so forth. So what happens then if I go from that term to that term, and from that term to that term, and from that term to that term, and so forth? So we can obviously see then, to get from 10 to 7, I need to subtract 3. To get from 7 to 4, I need to subtract 3. To get from 4 to 1, I need to subtract 3. So that means my constant difference is -3. Now, in this question, they are just asking for the general rule. They're not breaking up the question and sort of guiding you. We'll look at that later. So you are just being asked to calculate the general rule, but you need to know that the starting point is calculating our constant difference, which in this case is -3. By the way, our D, that stands for constant difference. So the D represents the constant difference. So what do I do after I've calculated the constant difference? Well, I need to, one of the ways that we've learned how to then work from here to get our general rule is to establish a link. Okay, so there's some kind of connection between the constant difference and the term position. Now that we have the constant difference, we need to find some sort of link between the constant difference and what's happening with the terms. Now, there are a few ways that we've learned how to calculate this general rule using the constant difference. And one of the ways that we looked at was linking the constant difference, in this case -3, with the term position. Okay, so we've got here, this of course would be term 1, that is term 2, that is term 3, and that is term 4, and of course it continues. Now the position here we're referring to is those numbers at the bottom there. So that is your term position, 1, 2, 3, 4. So if we can somehow link the constant difference of -3 with the position of the terms, we might be able to get some sort of rule here, or general rule. And we said that, well, let's look at term 1. Okay, so term 1 is equal to 10 in this case. So that is term 1. Now, let's see what happens if we say, well, let's take negative 3 and let's connect negative 3 with the position of term 1. So not with term 1 itself, but with the position. Now the position of term 1, of course, is 1, the first position. So I'm going to multiply this with the position of 1. Now, of course, remember we have equal signs happening here. So negative 3 times 1 is not equal to 10. Although it says that, if I look at this, what I've written here now, it says that term 1, which is 10, is equal to negative 3, because negative 3 times 1 is negative 3. Now, at the moment, this is not true, because negative 3 is not equal to 10. So the only thing that we need to then do here is, well, what can we do to make this equal to 10? Because then, that thing we can maybe repeat and see if it works for all the terms. So negative 3 times 3 is, negative 3 times 1 is negative 3. And in order for me to get to 10, well, I need to add 13. Let's see if this works for term 2 as well. If I take term 2 is equal to 7. And if I take my constant difference of negative 3 and I multiply it by the term position, which is 2, negative 3 times 2 is negative 6. And negative 6 plus 13 gives me 7. So it seems plus 13 works here again. Let's just do this one more time for the third term. So term 3 is 4. So term 3 is equal to 4. And if I take my constant difference of negative 3 and I multiply it by the term position, which is 3, and I add 13. Let's see. So negative 3 times 3 is negative 9, which is not equal to 4. So if I say negative 9 plus 13, that gives me 4. So it works. So we can see now that if I take my constant difference of negative 3 and I multiply or connect it with my position of the term and I add 13, then I can calculate the term value. So if I put that into a rule, so, well, if it works with T1, T2, and T3, we are wanting to find what is Tn. So then Tn, which we of course cannot put a number here, because we are, Tn is a general term, so we don't know what it is. It can be any of the terms in the sequence. So we can say, well, let's take our negative 3 and we multiplied the negative 3, which is the constant difference, with the position of every term. So in this case, our position is n. So we are going to say, well, that's n. And then we are going to add 13. So our general term here is Tn is equal to negative 3n plus 13.